Hello, thanks for coming to Peak PHP. If you haven't already signed up on the meetup page, please do so at peakphp.org or meetup.com/peakphp so you can get notified for our next meeting. If you'd like to speak, demo, or present at a future meeting, please let Brian or I know. This meeting is sponsored by Brian Parks, who unfortunately couldn't make it tonight. He's one of our organizers and has a few projects he's working on right now that are worth checking out at his website at brianparks.me, including virtual photo booths for Zoom meetings like this one. He's also open for consulting gigs. In the past, we've had pizza sponsored by Tech Systems, who is working overtime these days, helping all the newly unemployed software folks find new jobs. Brian can also connect you with them if you're also on the hunt. All right. And then let me share my screen and we can get started. Actually, so I'd like to talk a little bit about serverless. And then after a brief demonstration, maybe open it up to some discussion. Traditionally, most PHP web applications are hosted on something similar to a LAMP stack, which stands for Linux, Apache, MySQL, PHP, yeah, which is fine for hosting things like WordPress websites or Magento or any of the hundreds of free PHP applications out there. But there are some downsides to developing against a traditional stack. One of those is cost. If you pay for a small WordPress website, it's probably not going to be much to pay for shared hosting, somewhere between $5 and $20 a month. But for larger websites with millions of hits, it becomes very expensive to maintain web infrastructure, servers, databases, and all the things that go along with that, making sure that they're load balanced, that they're fully redundant, avoiding outages, which are all very expensive. Serverless has the advantage of scaling almost instantly. You only pay for what you use, so you don't have to pay. So if your website is most active, 3 hours a day, you don't have to pay for servers 24 hours a day. You can only pay for the request and the CPU time that you use, which is really nice for depending on the what you're doing with your application. So today I'll be covering AWS Lambda, which is Amazon's version of serverless, and that's broken up into each Lambda is basically I guess you could think of it like a container that you don't have to manage or a virtual machine that you don't have to manage. It runs somewhere in the cloud in a sandbox that just works, assuming everything goes well. And out of the box, it supports .NET Core, Go, Ruby, Java 8, Python, and Node, which PHP is not one of those. So I had to Amazon supports what are called layers, in which case you can use any arbitrary language, including PHP or Rust, or heck, you could even use Bash if you wanted to. I don't know why you'd want to, but and so what that is it allows you to create a bootstrap script, which then manages your processes, or in this case, our PHP application. That actually took hours and hours and hours of fiddling to get that working. There is an open source project that does all that for you, but they only support up to 7.2, I think. Not important. So first, let's go over Lambda. Let me see if I can share my screen. All right, so here's a GitHub repository I set up for building and compiling the PHP binary. And you can find that at the URL here. And so it's as simple as cloning it and then running the make script, which then spins up a Docker container and builds and compiles all the dependencies required to run PHP. And it bundles them into a nice little layer file. So in Lambda, layers are difficult to describe. So in this case, for a PHP application, you might have a PHP application layer, which contains the PHP runtime. You might have a composer layer, which contains all of your runtime dependencies, everything you need for testing, everything you need for whatever. You might have a layer for third-party dependencies or custom libraries. The layers can really be anything. You could have a layer for PHP and a layer for Rust if you wanted to run a low-level application as well as PHP. For example, with runtime exec or something of that nature. The layers can really be anything. And so you create a layer by going to the Amazon Lambda and clicking on layers and create a layer. So for example, PHP 7.4. And upload. So this whole process takes about 10 or 15 minutes. It takes a long time to compile and build PHP and all of the dependencies. So I will just runtimes license. So a lot of this is a little magical. And it just took a lot of figuring out. But what we're doing here is we're creating the PHP runtime layer, which we compiled earlier. And then we're going to create our layer. All right. And I already have one, which I've been testing with. And let's go to our example. So this is a PHP example function, which I created. And so in order to wire it up, we have to go to layers. We have to add the layer that we're going to use. I will remove this one. And then I have a simple hello world application. Well, it's really a hello tag application. So it reads the contents from standard in, decodes the JSON, and then prints out hello payload name. And then up here in my configure test events, I have a test event foo with JSON payload name : tag. So if we run this, we should see a JSON output with status code 200, body hello tag. The code that we execute is arbitrary. For example, we could do response has to be JSON encoded for the bootstrap that I created. There we go. We get a SHA-1 hash for our body. So the bootstrap is a little bit bigger than I can get into right now, but it's basically it's a control script for how to process the. It is basically what runs the code. So in this case, I'm telling it here to use the handler source/hello.php, which you can see in this directory is the file. And then it's running this code via the bootstrap and then formatting the response as a JSON object. So if, for example, you were to build your web application as build the front end to be completely static, you could host that in S3 and then use a reverse caching proxy like CloudWatch or Cloudflare to load your web application, and then have all of your backend written in PHP using Lambda. And depending on what your web application is doing, it could save hundreds or even thousands of dollars a month, maybe even tens of thousands of dollars. You get 400 some odd thousand, 200,000 megabyte minutes per month free of Lambda. So for a small application, it might even be completely free or very, very cheap because you still have to pay for storage. And then you also have to pay for if your application accesses a database. That unfortunately, there's not really a good way to get around that. Because Lambda is run in a sandbox, you could do it's really difficult to do like without persistent storage. It's difficult to do like a MySQLite database or anything of that nature. Amazon does have serverless Aurora, but if you leave it up all the time, it takes a little time to spin up, so it's not really good for completely serverless applications. Some things to be aware of with Lambda are what's called a cold start. If you haven't run your Lambda function, like this hello, in a while, where a while is an arbitrary period of time, Amazon doesn't really specify what, as far as I know, what the timeout is. It can run into what's called a cold start, where it takes a little bit more time to spin up the sandbox to test the application. So sometimes the first time you run it, it'll take a little bit longer. This isn't really a big deal for most things, but if you're in a performance critical application, it's something to be aware of. What else? This would be really, really great for background tasks, like to replace cron, for example. You can, let's see, I think it's CloudWatch. No, it's, let's see. Let's see, events. Yeah, so you can create a rule, and just like cron tab, you can schedule. In this case, we'll just do it at a fixed rate of 5 minutes at a target, our Lambda function. PHP example. And that should happen every 5 minutes, which is really quite useless because it's just going to print a payload. But so we could, for example, if we were scraping something that we wanted to get periodic updates on, if we were to scrape a website with curl and an HTML or XHTML parser, that could be a really useful way of gathering data or statistics over time. There are all kinds of cool things we could do with it. Well, just like cron, but without having to have a server that's up all the time. And also, scheduled tasks can often be CPU intensive, especially if you have a bunch of tasks all scheduled at the same time. With serverless, you don't have to worry about that. With Lambda, you can call other Lambdas, just like with any language. Some things to be aware of are that its CPU scales with the amount of memory you have configured. So right now I have the timeout set to 3 seconds, and with the minimum amount of memory it'll allow. But as you can see, PHP is fairly efficient, and so for a simple print, it's using, looks like it maxes out at 69 megs. So that's probably mostly the runtime overhead. And then also to be aware of with Lambda is that we don't have shell access. We can't, because of the nature of the sandbox, we have to do all of our, prepare all of our work in advance. So yeah, that's pretty much it. This opens up a whole world of really cool things we can do without having to pay for persistent server infrastructure. A lot of shared web hosts, for example, don't provide shell access, so it can be difficult to. Well, sorry, rambling. Yeah, let's go back to Zoom. Anyway. So are there any questions? Is anyone familiar with serverless? I'd be interested to hear how you're using serverless. So my background is very DevOps heavy. A lot of the tools that I've created over the years, oftentimes like they provide enormous value, but half the battle is just finding a place to put them because they may not have anything to do with the primary web application, or they may not. You don't really want them on a production server when it's prototype code. This allows you to rapidly develop small tools and applications and deploy them without having to set up a whole environment. Installing a web server, the database, all that stuff. And then also with Amazon provides a service called, what is it? The Amazon API Gateway. So you can create full-blown APIs using the Amazon API Gateway, and it'll automatically, well, not automatically, it'll reverse proxy to Lambda transparently, so it looks like any other web application, which is really nice. This basically eliminates almost a large portion of having to manage web infrastructure. Anyway, that's all I have. Are there any questions?